Our speaker today is Dr. Christine Michienzi, founder and CEO of MMR Defense Solutions, LLC. Dr. Michienzi will discuss a topic of great interest to the participants in the Mackinder Forum, industrial mobilization, issues and solutions. She has served in the office of the Secretary of Defense, where she was Senior Technology Advisor for Acquisition and Sustainment, advising the USD and other senior DoD leaders on innovative solutions for the design, development, and production of DoD systems. Dr. Michienzi began her DoD career with the Navy, where she served as the Missiles and Munitions Technical Expert in the Program Executive Office, Integrated Warfare Systems. She spent nearly 2 decades at a Navy laboratory developing new explosives and propellants for DoD weapon systems and eventually became the Research Development Test and Evaluation Department head, leading over 140 scientists and engineers performing research for Navy weapon systems. She received both the Naval Sea Systems Command Scientist of the Year Award and the Assistant Secretary of the Navy for Research Development and Acquisition Scientist of the Year Award for her research achievements. Dr. Michienzi received her Bachelor of Science degree in chemistry and her doctorate in analytical chemistry from the College Park campus of the University of Maryland. Before we begin, I would like to remind everyone that we operate under the Chatham House rule. Participants are free to use the information discussed, but they cannot attribute it to a specific speaker or reveal the identity of other participants. In addition, during the question and answer period, please be brief. Do not lecture the speaker or the audience. The talk will be recorded for posting to the web. I want to remind people that on June 16th, 2025 in Washington, D.C., the Mackinder Forum will host its first in-person event since the onset of COVID. The topic will be the New Monroe Doctrine, Greenland, Panama, and Canada. For further information, please contact Ms. Christine Clay. And with that, Dr. Michienzi, please.
Thank you, and really appreciate being here today with everybody to discuss this important topic. I'll just add one thing to the bio. In addition to working directly for the Undersecretary for Acquisition and Sustainment, I spent 8 years in the Industrial Base Policy Office at the Office of the Secretary of Defense, which is all things supply chains and trying to make sure DoD has all of the systems it needs. So that's really where a lot of the focus of my talk today is going to be about. So happy to be here today. Thank you again for the invitation, and thanks for all who are participating. I'm going to go ahead and have a series of slides. I'm going to try to go through them quickly because I think the question and answer period is always the most interesting thing. So I'm going to go ahead and share my screen. Just a little bit of background about industrial base and national security writ large. Really, I like to say that the general public wasn't really aware of the fragility of our supply chains necessarily until COVID happened. And suddenly, because of the microelectronic shortage, there was a shortage of cars available for people to purchase. The baby formula shortage is obviously one that got a lot of press. So it wasn't really until then that sort of the general public was aware of how fragile supply chains were. The Ukraine conflict has just emphasized that, and this is supply chains for both commercial products and DoD systems. We didn't get here overnight. A lot of people were unaware, but this has been something that's been happening for quite some time where, the private sector and public policy really prioritized low short-term costs over security, sustainability, and resilience. So the industrial base, both commercial and DoD, has been optimized for efficiency and not resiliency. And unfortunately, when we've had these shocks to the system or crises, we have found out very quickly that we are not optimized for resiliency, and we face severe shortages. We've prioritized just-in-time deliveries versus inventories of long lead time components. We've typically call that sort of the Walmart model, which really cuts warehousing costs and again increases efficiency, but limits our flexibility and responsiveness. We have become a system of a lot of single and sole source suppliers, especially in the DoD industrial base, defense industrial base, and often those are unfortunately foreign adversarial sources, which are cheaper but less reliable. In a way, DoD acquisition processes incentivize this behavior because given two equally technically acceptable proposals, which one would DoD pick? Obviously the cheapest one. And so there's not going to be a company that's going to risk losing out on winning an award because they're using a more expensive domestic or more secure allied source, unfortunately. So we've sort of, gotten ourselves into this situation. We've gotten critical capabilities that have been driven offshore, which introduces risks. Just a couple of examples, and I have some graphs to show you some additional data, but for rare earths, which are used across the board in many DoD systems and also many commercial systems, the US was the world leader until the 1980s, but now China controls 85% of the global refining capacity for those materials. And semiconductors, US production has fallen from almost 40% to just over 10% in the last 40 years. So there have been multiple executive orders in many administrations and also legislation. CHIPS Act is sort of the poster child here that are trying to help address these issues. Just a couple of graphs just to illustrate the points I made on the previous slide. You show on the top left here the share of the top 3 producing countries in mining of selected minerals. So keep in mind, producing critical minerals is a multi-step process. There's mining, but then there's processing, and then going into finished goods like magnets, for instance. So in mining, you can see on just the couple of examples shown here on the left, rare earths, obviously we talked about China's dominance. They also have a big dominance in mining in that particular industry, also graphite. For some of the other really important ones like lithium for electric vehicles and batteries, cobalt for batteries as well, nickel, copper for many applications, China doesn't really have a monopoly or a large share of the market in mining. But if you move to the bottom graph, you can see processing of those same materials. It's a much different picture. China dominates the processing of many of these materials, and that's where the problem lies. A lot of people, when they're trying to solve the critical minerals problem, point to we need more mines. We don't really need more mines. There's plenty of mines in the US and allied countries. It's really the processing that China is dominant in. So it doesn't make sense to really spend a lot of effort, not that we shouldn't spend some, but not a lot of effort in mining if we're just going to have to ship those materials to China to get them processed. So really the focus needs to be on the processing piece of this equation. In the next graph, you can see same kind of thing illustrated here, where it shows where what the US important reliance on China by mineral type is a percentage of consumption. So the dark red bars is China is the primary import source, light red bars is a secondary or tertiary. China is not a significant source in the gray bars. So again, you see cobalt, for instance, where China is not the primary source, but if you go down to cobalt down here, you can see in the processing piece of it and the producers of the finished critical minerals, cobalt is largely China dominant. So just another way to show this kind of data where we definitely have a large reliance on China in this area. Semiconductors, although not dominated by China currently, they are really ramping up efforts to really capture market share in this area. Currently, it's dominated by other countries in the Asia-Pacific theater. TSMC is in Taiwan, and so is UMC, and they dominate the market in this area. Samsung is in Korea. They also have a large market share. You can see the US is represented by Global Foundries on the bottom right, and there's also US companies in the others, 8%. I mentioned before, the US has about 10% of share of the market. So there's other companies like Intel and Texas Instruments that produce semiconductors in the US, but we are by far a small share here. And the problem here is, that even though China is not a dominant percentage of the market, you can see that with Korea and Taiwan, most of the semiconductor manufacturing is in the Asia Pacific theater. So if China decides to invade Taiwan, we are going to be in big trouble, because you can see the dominance there that Taiwan has on the semiconductor market. And even getting things out of South Korea in a contested environment is going to be difficult. So this is another key risk area where we have, offshore capability and not enough domestic capability. So, there's been a lot of discussion recently about industrial policy. Typically, the US does not like to use industrial policy. We operate as a free market society, and this is okay as long as there's a level playing field. But as we know from decades of history now, this is not and has not been the case for a long time. Many countries, and especially our adversaries, don't play by the same rules. They subsidize their industries. A lot of them are state-owned enterprises. They encourage overproduction to kind of flood the market or dump on the market, which drives pricing down, which then drives out competition who can't be cost competitive, especially in the US, where we're already facing higher costs to start with for manufacturing. That captures market share, which then monopolizes the market. China has used this to great effect to capture and dominate markets such as rare earths, as I mentioned before, and is now attempting to do so for semiconductors. This advantage can also be weaponized, as we have seen very recently. China has done this most recently with export controls on gallium and germanium, which are used in many industries, including the semiconductor industry, graphite and antimony, among others, which are very DoD, largely used in the Department of Defense. So the U.S. has started to realize and understand that there needs to be some level of industrial policy for us to be able to compete and to be able to have secure sourcing. And so the CHIPS Act I mentioned before was, the legislation and the appropriation to onshore semiconductor manufacturing in the United States. So that's one example of industrial policy. The Defense Production Act, also used by my previous office in industrial-based policy, makes investments in domestic and allied industrial sources as well. So those are examples of where we can and have used industrial policy very effectively. Buy American. I always like to bring this one up because people always point to that. Well, let's just use Buy American to fix this problem. But the problem is that the Buy American legislation, although well-intentioned, is not really designed to accomplish the goal that it's trying to produce. So I always ask the question, what is this legislation really trying to accomplish? Are we trying to increase domestic economy and economic growth, therefore economic security? Are we trying to increase national security by reducing reliance on foreign sourcing? Does that apply when it's even allied and partner sourcing? Some of whom may have better technology. Is that what we're really trying to achieve here? Limiting the use of those sources. And currently, with the legislation the way it is, you can have 65% of your system from America, but have all of your most sensitive components come from China. I mean, that's the way the legislation is written. You could actually have a system that is like that. And so is that really what we're trying to achieve here? I don't think so. So in my mind, it should, the Buy American legislation could be used more effectively. And so instead of using a blanket percentage, it should be targeted at what are most critical from a national security perspective items in these systems. So again, instead of that blanket percentage, say, okay, your most critical technology systems need to be from America or allied sources, for instance. Additionally, Congress usually only levies these requirements on DoD. DoD is a very small percentage of the market. So DoD is not driving the market in things like rare earths and microelectronics. We're about 1% of the total US market. And so, saying DoD has to can comply with this legislation really doesn't move the needle. If they're really serious, they should insist that other agencies are held to the same requirements as DoD, so the combined strength of all the government can work towards achieving the goal. Also, it's too easy to get a waiver by claiming there's no capability in the U.S. to produce the item. And, unfortunately, that is true in most of the cases where waivers are sought. But there's really no follow-on from that process. So, in my mind, if someone's applying for a waiver, they should look at using non-adversarial sourcing instead of just saying we're going to continue to buy it from China. So they should look at allies and partners. We did finally get some legislation like this passed in the FY24 NDAA for certain critical chemicals, and we're working on additional legislation in this area. But it should also spur investment to develop and qualify a U.S. source, and Congress should help appropriate funding to do this. They're really fond of imposing these restrictions, but not giving a way to have a solution to the problem. So they really need to step up and appropriate funding in addition to just making these requirements. So I'm going to switch kind of to DoD, centric here for a minute because that's what I'm most familiar with. DoD has been developing mitigations for a lot of supply chain shortfalls in critical areas for decades. But most recently in the Biden administration, they issued an executive order 14017 called America's Supply Chains. And the DoD report in response to that executive order identified 5 critical areas that the DoD was going to focus on making investments. And it's not that other areas aren't important, like shipbuilding, for instance. They absolutely are. These were just the areas where we felt that because I was very involved in writing this report, we felt that we had a large foreign adversarial dependence. And so really trying to prioritize investments in these areas became important. And so OSD, the Office of the Secretary of Defense, has 2 different funding streams, the Defense Production Act Title III and the Industrial Base Analysis and Sustainment funding. And so this provides a framework for those investment programs to try to tackle this huge problem of foreign adversarial sourcing. So again, mitigations involve onshoring critical capabilities, but not as sole sources or Buy American, and then working with partners and allies. And I'm going to talk a little bit more about partners and allies later, so we won't go into more depth in that now. But I always stress, and with Congress especially, and with industry, most people are focused on the supply side of the problem, but this is a two-sided coin. Supply is one thing. You can build additional supply, and that's great. But the demand side is equally, if not important, and that's the part that usually is either forgotten or overlooked or considered kind of a secondary thing. But in my mind, it's equally important. We need to understand what drove demand to non-U.S. and adversarial sourcing in the first place. Was it macroeconomic issues? For instance, market capture? Was it for investment? Is it cost? What is it that drove that sourcing offshore, and how do we fix that problem? Because we need to drive demand back to the U.S. and ally nations to make the capabilities that we're investing in sustainable. If not, then we're just wasting our money. It's not built, they will come. They're not going to come. So we need to figure out a way to be cost competitive, for instance, using things like additive manufacturing technologies, which I'll talk a little bit more about later also, but also things like industrial policy, subsidies, tax credits, workforce training incentives at the federal, state, and local level to make sure that this is a holistic solution. There's also policy solutions which talk about, again, you can't use certain strategic materials and DoD systems. Those are somewhat helpful, but again, if we're not trying to develop new systems to mitigate that issue, then it's really just a stick with no solution. And then we need to bolster our R&D initiatives in the U.S. and with allies, maintaining the edge in design and IP, where the U.S. has always dominated. The U.S. still dominates in the design of semiconductors, believe it or not. Even though we have almost no capability to produce them ourselves, we still dominate in the design, for instance. So keeping that edge in design and IP keeps our adversaries dependent on us, and it also excludes them from technologies that we don't wish them to have. So let's talk about defense industrial base flexibility and surge capability. I was the lead for scaling up the production of all the weapons systems we were sending to Ukraine. I had done that role, trying to mobilize the industrial base for various crises over the past 6 or 7 years before I retired, and some certain key issues and causal factors really come to light as we look at how do we do that. So again, Russia's invasion of Ukraine really brought into focus the importance of being able to surge production rapidly, as well as the challenges in doing so. I will tell you that we have gone through this cycle so many times, and we know what some of these are, and we've known them for quite some time. And when the crisis happens, we attempt to fix them. But unfortunately, when the crisis is over, we have short-term memories and we kind of go back to our old ways. But for now, we'll talk about the DoD lacks flexibility and surge capability in the industrial base for almost every system it procures, which affects our readiness and mobilization. We found out during Ukraine that this is the same for allied production. We searched the world, for instance, for 155 millimeter ammunition, which was a key piece and still is a key piece of weaponry that the Ukrainians are using against Russia. And we found that allies also lack flexibility and surge capability for most of their defense industrial base as well. Over time, the defense industrial base has been optimized for peacetime. We haven't really been in a wartime situation, a true wartime situation in quite some time. And so production lines have gone cold. We've let parts go obsolete. Sub-tier suppliers have consolidated or gone out of business entirely. I mean, we don't have enough demand to sustain certain capabilities. Industry right sizes to the DoD demand. I say always that we have the defense industrial base that we paid for. And these are conscious decisions that were jointly made by the department and by Congress in the face of competing priorities, because it's a zero-sum game. The budget has the top line, and so they are always looking for ways to move money around to fund priorities of the day. So munitions, unfortunately, which I'm most familiar with, are often used as bill payers. They're fungible accounts. It's very easy just to cut a couple hundred, purchases of munitions and ship that money to something else. And there's always a plan to make up that buy in the out years, but that typically never happens. So munitions are historically underfunded and funded in a feast or famine fashion. So you can look at the graph on the right-hand side there, the bombs purchased, per fiscal year, how feast and famine that is, where we're buying a lot and then we buy almost nothing, then we're buying a lot and then we buy almost nothing. So that is not the graph that you would like to see if you want to have a healthy and resilient industrial base. You'd rather see it more flatlined, and DoD just and Congress just don't understand that is why we have the industrial base that we have sometimes. So, when the next conflict or stress to the industrial base occurs, DoD has to pay to reconstitute all that lost capability, which is really, not the most effective way to do that. Additionally, with regards to Ukraine, no one really anticipated the prolonged high volume conflict we've been seeing. I mean, honestly, when the Ukraine conflict broke out, we thought it was going to be over in weeks in the Pentagon. And so, the fact that it's gone 3+ years is just, mind blowing. No one really realized that. And the use of really, non sort of, complex munitions, precision guided munitions. It's really been the more simpler kind of regular rounds that have been used, and we don't typically think about using those against near-peer competitors. So the U.S. has donated, over 2 million rounds of 155 millimeter ammunition. The Ukrainians shoot thousands of rounds of this a day. And the global industry, remember I told you we did a search for worldwide 155 millimeter production. It can't keep up with this level of demand. And so it's, become a big issue. And so in times of crisis, like I said, I've been doing this for 6 or 7 years. DoD attempts to surge quickly, but faces many constraints. So here's kind of the top 5 constraints that we see almost across the board every time. So insufficient capacity, again, I talked about DoD doesn't pay industry to maintain surge capacity, so they're not going to. They're not going to have people sitting around doing nothing. They're not going to have run machines, if they're not being paid to do that. So shared sub-tier suppliers is a huge issue, and this is something that the DoD lacks a lot of and even industry lacks visibility into, especially at the lower tier levels. there's a lot of subcomponents and materials and components that are shared in production lines that are shared between different systems, and there's really not a great visibility into that to understand where the demand is. People just go, oh, I'm going to surge this munition, but not realizing that this subcomponent is also using 3 other munitions, and so there's an issue there with capacity. Great example that I talked to Michael about the other day was precision ball bearings became a major constraint when we were scaling up missiles, because they are used in exquisite guidance systems. So these are not ball bearings you go buy at Home Depot. These are precision, exquisitely machined ball bearings. There's one company in the U.S. that is qualified to make these ball bearings for DoD munitions, and they had 140 back orders for DoD systems. So we quickly identified that as a major constraint and bottleneck, and we actually funded them to increase their capacity, but also to modernize their capability. Unfortunately, at the very low sub-tier levels, these are low profit margin businesses. Primes are making a lot of profit, and they do that by squeezing out their sub-tier suppliers' profit. And so these folks are very low profit margin companies. They don't have the money to innovate. They don't have the money to modernize. They don't have the money to expand capacity. So we stepped in and funded them to do those things. Insufficient workforce is always an issue. One of the easiest ways to ramp up production is to add a shift if you're not already working 24/7, but you have to have people to do that. And a lot of times that's an issue, obviously. Attrition doubled during COVID. A lot of these plants that manufacture munitions especially are in undesirable locations. And I don't mean that pejoratively, it's just that you have to be in the middle of nowhere when you're making explosives. And so unfortunately, if you're in the middle of nowhere, it's not a great place to live sometimes. And young people are attracted to innovative work, and working in a factory, making shell casings is sometimes not viewed as very innovative work. So we have problems with workforce across the board, not just in munitions, but in every industrial base sector. Obsolescence is a huge issue, chronic issue for the Department of Defense. Department of Defense fields their systems for decades in many instances and does not keep up with technology refreshes. So, you get a new iPhone every 3 to 5 years because the technology becomes outdated. DoD keeps their systems in 25, 30, 40 years sometimes. And so they're constantly facing obsolete parts because they don't have an efficient way to do tech refreshes, and I'll talk a little bit about that later. Long lead time items is a huge issue that comes with that just-in-time delivery model where we don't have stockpiles of things, and so that's what drives the total production time of these items. So not having a stockpile of critical long lead time items becomes a major issue. Also, people don't understand that even if you can increase the capacity, which takes months or even years, then the deliveries of that increased capacity don't come until years afterwards due to production lead times. Production lead times for a typical missile or munition is 18 to 36 months. So you're talking, a year and a half to 3 years just to make a munition. So even if you increase capacity to today, which that takes months or years unto itself, you're not going to realize that increased capacity for another couple of years. So that's another realization that's overlooked. So moving forward, what can we do? Just need to have a recognition, and unfortunately, we get a lot of DoD. We have a lot of political appointees that come in every administration that don't have experience in this area, and so are not familiar with how the defense industrial base works, and don't realize that you just can't turn off complex production lines, based on the requirements a day, and you can't just turn them back on. It's not like flipping a light switch. Industry is reluctant to build additional capacity. I talked about that earlier. They need a clear, consistent demand signal. And you remember that graph that I showed you, feast and famine, we don't give that to them because they can't make a business case to increase capacity. They need some kind of degree of confidence that if they invest, they'll get something for their investment, like sustained production. So they need a return on investment to justify that. We need to stabilize the industrial base and build it for the future, ensuring that we're delivering capabilities. So a couple of things that we worked on were multi-year procurements. We begged Congress for as long as I was in the Industrial Base Policy Office, 10 years, to allow us to do multi-year procurements. DoD is funded just on a 1 year basis. That's what the budget is, and so typically they buy 1 year's worth of stuff. If you could allow them to do multi-year procurements, that would level out that budgeting graph that I showed you, because you could ensure for at least say 3 to 5 years industry that, hey, we're going to buy this at least minimum amount of this thing, and it doesn't have to be munitions. We actually do use this very well in shipbuilding, for instance. But then it allows them, it gives them the confidence that they can invest in their capability, surge capacity, modernization, for instance. But Congress is reluctant to do that because it ties up the money. They don't talked about money being fungible. They want to move it around to different accounts for different priorities. So it ties up the money, and they don't like to do that. The services don't like to do it for the same reason, because it ties up the money, and they want to be able to move the money around. But really, that's what you have to do if you're going to have industry, be resilient. Advanced procuring long lead time items. I talked about that being one of the major constraints. Congress doesn't like to do that either. They consider it to be early to need, and they worry about items being on the shelf and becoming obsolete before we use them. But we kept stressing that this is going to be critical items that are used in multiple systems that will definitely be used. We'll keep rotating inventory. In the FY24 NDAA, they did give permission for procuring long lead time items, but only for obsolete parts, not for parts that we need for current systems. And again, no appropriation, just authorization. Same with the multi-year procurement, only authorization, no appropriation. Industrial-based health needs to be one of the criteria when making acquisition decisions, not just cost, schedule, and performance. I actually wrote an op-ed about this. And we need to consider industrial-based impacts when making those budgeting decisions. It does cost more to even out procurements. If you buy, 100 of something in 1 year versus buying 20 of something over 5 years, you get economies of scale, you get price breaks, but again, it doesn't lead to a healthy and resilient industrial base. So you need to think more long-term when you're making those kinds of decisions. Avoid using munitions as bill payers, talked about that. Maintaining a certain amount of industrial capacity, in some cases multiple sources for critical components, materials, and sectors. We have single and sole sources for many hundreds of DoD systems, both within the US and partners, and that will help us surge more efficiently. Additional factors, addressing the macroeconomic issues that make our supply chains fragile, such as adversarial market capture, CFIUS, if you're familiar with that, Committee on Foreign Investment in the United States. That's when any foreign actor, not just an adversary, tries to buy a US company. That's reviewed by a multi-agency committee on foreign investment in the United States that decides whether that's in the best interest of the United States. So DoD weighs in from a national security perspective. So we need to use that and other authorities and incentives to ensure we sustain those key capabilities. Need to use all available authorities. Talked about the Defense Production Act as an industrial policy to bolster our capabilities, to make sure our inventories are sufficient. We need to be more innovative, agile, and flexible. DoD does. Making the acquisition process itself more innovative. That was one of the things I was looking at right before I retired for the undersecretary. So things like doing design and manufacturing at the same time instead of linearly, kind of the SpaceX model, right? Contracting, innovative ways to do contracting, other transaction authorities, middle tier of acquisition, for instance, if you're familiar with those two terms. Using digital engineering and modular open systems architecture, or MOSA, will really help mitigate the obsolescence issue that we have. And it also allows for tech insertion, which provides increased capabilities for these systems in some cases. Advanced manufacturing techniques, again, I'll talk about that a little bit more. They're more cost effective, more efficient, enable faster production. For instance, need to partner with allies and partners. Talk about that in a minute. Things like co-production. And then continue to use small, innovative businesses. Small businesses, priority usually in the government, using small businesses. They do bring fresh new ideas and technologies to our systems that make them be manufactured sometimes more efficiently and cost effectively, and give us those better capabilities that help deter or defeat our enemies. So a resilient industrial base is a deterrent. If China understands that we can manufacture sufficiently and and effectively, that is a deterrent to them. So people don't understand you can use that as actually part of your deterrent strategy. So let's talk quickly about it in additive manufacturing techniques. There's a lot of different ones. I mean, 3D printing is just one of those kinds of things, but there's many advantages to that. They speed up innovation. You're able to, in many cases, prototype and test many versions very quickly, versus things taking months or even years kind of to manufacture and then test. Some new technology aren't possible without additive manufacturing. You look at that picture in the upper right hand corner, that would be very difficult to manufacture subtractively, which is where you take a piece of metal and then subtract out the metal that you don't want. That would be very difficult to do that design that way, but it is able to be done versus in 3D manufacturing. So things like liquid rocket engines have really grasped that concept. SpaceX uses additive manufacturing a lot in their systems, just as one example for that. So, and then some manufacturing is made less hazardous by using additive manufacturing. So there's biosynthesis of chemicals, not just for DoD systems, but for others. It reduces or eliminates environmental issues that are really issues with a lot of things like producing chemicals, but also producing critical minerals and rare earth elements. Those are very not environmentally friendly processes. So if you can use biosynthesis for some of this, that really helps with that issue. And then things like microfluidic reactors and resonant acoustic mixing are examples of advanced manufacturing technology for mixing of explosives, which reduce a lot of the safety hazards. And then you maybe don't have to, put your plant in an undesirable location where nobody wants to work. And so additive manufacturing solves a lot of the supply chain challenges that we have in a more efficient and cost-effective manner. However, many of the defense industrial base facilities, especially the government-owned or smaller suppliers, have not been maintained or updated in decades. I talked about the smaller suppliers; they just are such a low profit. They don't have the money to do that. The government-owned facilities, unfortunately, have not been prioritized in the budget. You walk into some of these facilities and it's like walking back into World War II, processing equipment and procedures. So really need to make sure we are emphasizing those. Traditional manufacturing techniques still able to produce items, they're just not as cost effective or efficient in some cases. There's a lot of waste and rework, for instance, so that additive manufacturing part I showed you on the top right hand corner of the previous graph, if you have to subtract that out, I mean, all that material that you're subtracting out is just waste at that point. It can be recycled in some instances, but it's still just a lot of waste versus, the additive manufacturing way of making it. U.S. can't compete with other industries and nations, especially the state-owned enterprise type of nations. We talked about that. We need to be cost-effective in order to bring back that demand, because that's what's kind of led to offshoring of critical capabilities in some instances. Companies become constraints. I talked about the ball bearing systems. We gave them $13.8 million of Defense Production Act Title III investment to modernize and expand their capability. But there's resistance in some areas, of the country and an industry that comes from concerns about that robots are taking American jobs. And this is really due to a lack of understanding and education about, educating folks about what additive manufacturing really is, advanced manufacturing really is. It's not that they're not educated, it's just a new concept. That you'll still need personnel, they'll just be performing different jobs. All those robots need people to maintain them and fix them. So, it's not that we're replacing people in a lot of instances. There may be some reduction in workforce to be more cost competitive and efficient, but it's not, one-for-one replacement. And there's also a lack of realization that if U.S. can be more cost competitive, more work and capability will come back to the U.S. and that actually creates more American jobs. So this could be, a definite benefit. However, advanced manufacturing will never completely replace all traditional manufacturing. A lot of people talk about we don't need castings and forgings anymore. And if you noticed in one of the first slides I showed, that was actually one of the top 5 areas that DoD identified as being really heavily foreign adversary dependent. There are just some very large parts that are traditionally cast or forged that it's very cost effective to do it that way, and you're just never going to be able to do it without manufacturing in a cost effective manner. So it's a complement to, not a replacement for, all traditional manufacturing. There's also, unfortunately, large costs and timelines associated with qualifications of parts made with these new manufacturing methods. So that's something that DoD is trying to tackle. Congress is trying to force them to be more efficient on that. There was language in last year's NDAA about doing a pilot on trying to figure out how to qualify new materials and new parts more quickly and less costly. We did use additive manufacturing in Ukraine a bunch. Parts for sustainment became an issue. We just didn't have enough of some things to send to them. So, or we couldn't supply them quickly enough. So the Ukrainians are very resourceful in many, many ways, but they just were starting to 3D print parts in theater. I mean, we couldn't get them firing pins for the 1.5mm howitzer, and so they just 3D printed them in the field. So it's been used to great effect in that particular way. So let's switch over real quickly to partners and allies. Key component of the defense industrial base. It's not always Buy American. It's important that the U.S. has capability for certain critical technologies and critical materials and subcomponents. It's very important to produce its weapons platforms. So not saying we shouldn't have that. We need that in many instances. However, U.S. has never had and will never have a completely industrial base. It can't and it shouldn't. Again, for certain key critical capabilities, yes, but not everything. And in fact, there's a lot of cases where we shouldn't. I talked about demand earlier. U.S. demand for some of these materials and components is very small, even though the DoD budget is enormous, going to be $1 billion or $1 trillion this year, right? We still don't have enough demand to sustain even a single supplier for some capabilities. For some chemicals that we use in our munition systems, we buy like 10 pounds a year. So it's like no huge chemical company is going to waste their time making 10 pounds of something. So we need to work with allies and partners and pull that business case together to have multiple customers to make sure we sustain that capability where it makes sense. I talked about there also may be better technologies in partner and allied nations that would provide better capabilities for our warfighters. So why wouldn't we take advantage of that? And it also may be advantageous from a logistics perspective to have production capability in or near theater. So I'll talk a little bit about that more, but that, if we have the capability, that's what AUKUS is all about, right? About having capability to produce submarines in Australia and having capability to produce other weapon systems in Australia, for instance, guided weapons, explosive ordnance program. So having the ability to not have to produce it in the US and ship it all the way over to the Asia Pacific theater, having something in theater does provide advantages. So there's 4 main ways to collaborate with partners and allies. There's co-development, where you're developing something simultaneously with a partner and ally. Co-production, where there's multiple people producing parts of a system. License production, where, for instance, Japan licenses F-16, South Korea licenses the F-16 aircraft to produce it there. And then leveraging capability to mitigate U.S. issues and shortfalls. That's the one I want to highlight because everybody's really focused on the first two. That's kind of what I call the bright, shiny object. So let's talk about co-development and co-production first. There are some great examples here. F-35 is obviously the poster child. There's 8 countries. There were 9 before we removed Turkey from that system. ESSM, involved sea-faring missiles, also a good example. That's a NATO consortium of 12 countries. SM-3 Block 2 missile, which is a co-development, co-production between the US and Japan. Licensed production, I talked about the South Korea F-16 example, and then leveraging capability, an example is carbon and rayon fibers from Japan are used in hypersonic glide bodies and nuclear reentry vehicles. But many countries, again, aren't interested in anything but co-development, co-production. And there are very few opportunities to do that. There just are not new systems being developed all the time. So that opportunity is much smaller. It would be really, and it's the most difficult to execute actually, it would be in it, but it's difficult to convince them otherwise. Really leveraging capability to mitigate shortfalls is the way I believe we can leverage partner and ally capability much better. So for instance, I talked about the fact that we looked all over the world when we were scaling up production of systems for Ukraine. And we were looking at not just who produced 155 millimeter ammunition, but who produced the propellant for 155 millimeter ammunition, who produced the cases, who produced the explosive fill. So we were looking at components and materials and addressing shortfalls with partners and allies in that area. And that's really where there are much more opportunities to partner. I'm not going to leave this slide up for more than a second. You can get it. This is just off. Rand did a study on barriers to partner and ally collaboration. I'm going to highlight a few of these that I think are the most important, but there are barriers to doing partner and ally collaboration, as I'm sure you all are aware. So export controls obviously is the big one that our ally partners always cite. You know, ITAR, technology transfer. It's an issue. We are not wanting to share our most elaborate technology, exquisite technology with certain partners. And even when we decide to share, it becomes very difficult. The mechanisms to do that are not efficient. Overclassification. DoD tends to slap no foreign on a lot of documents when that's not really necessary. You could do REL, release to Five Eyes, release to, you know, Canada, US, Australia, for instance, and we tend to just slap no foreign on everything as a default, and that really needs to be changed because it's very restrictive. Cultural policy can be an impediment. The EU released its own defense industrial strategy. The US produced theirs as well. And in that strategy, the EU calls for increasing capability inside the US and leading to less collaboration, buying less things from the United States, collaborating less, producing more in the EU. You know, that's great. I don't think they're going to be able to do that, you know, solely, just like we don't have a completely domestic industrial base, they won't either, but we do need them to have capability. I mean, because Russia is still a credible threat, and so we need them to have capability in theater, and again, develop some capabilities to mitigate some of our issues. Japan just revised its principles on the positive for transfer of defense equipment and technology, which is leading to increased collaboration. So there's constant cultural and policy developments that are happening in this area. One of the barriers is unsynchronized planning and funding cycles. We operate on a fiscal year. Some people operate on a different fiscal year. Some people operate on the calendar year. We're a 1 year cycle. Some people are 2 year cycles. So it just, you know, syncing those together becomes almost impossible sometimes in order to have the funding line up in the right time frame to execute some of these things. However, we do have many collaborative agreements, and some are more successful than others. There's the National Technology Industrial Base, which is Australia, Canada, UK, US, AUKUS I talked about, and then the Quad. Those are just a couple of examples where we are really making some headway. However, some countries are more challenging to collaborate with than others, so it becomes difficult in some instances to have collaboration, and we need to be careful who we're partnering with. Countries that are partners and allies today may not be tomorrow. So, you know, the perfect example is when Turkey wanted to buy S-400s from Russia, and because we couldn't give them Patriot systems fast enough, I was very involved in that. I did a war room on Patriot to figure out how we could make them faster. And they just didn't want to wait. And so they bought Russian S-400s, and we kicked them out of the F-35 program. So it's, you know, difficult sometimes, you know, because priorities, you know, change sometimes. I think just the summary real quick, you know, unfortunately not good news. The U.S. defense industrial base is not healthy, is not resilient, and cannot surge production when needed. So that's unfortunately a fact. There's a lot of efforts ongoing to try to mitigate that, but it is troublesome when we have continued conflicts in Ukraine and Israel and the instability in Indo-Pacific. So we are being pulled in a lot of different directions, and we were already sort of not in a good place to start with. I always emphasize that it's going to take a whole of government effort to fix this problem. It's not just DoD that needs to be solving this problem. It's also going to take many years. We got in this situation over many years, and it's going to take many years to fix it, and a lot of funding to reverse the damage we've caused and rebuild that capability and capacity. So just a couple of examples here. You know, trade policy from Commerce and USTR are helpful sometimes. Workforce development from Department of Education, critical infrastructure, energy and interior, logistics, Department of Transportation, moving things around. So it's just all of those agencies need to be rowing in the same direction. And right now, there's competing requirements, there's competing priorities in certain instances. The famous one I talk about is CFIUS cases. You know, DoD looks at it from a national security perspective, but Commerce, for instance, looks at it from a economic security perspective, where, you know, DoD is like, well, this is, you know, important technology. We don't want to give this to our adversaries. But Commerce is like, yeah, but they're going to bring jobs to the U.S. and, you know, they're going to bring money. And so those are competing priorities. And believe it or not, DoD loses that argument sometimes. And so there needs to be an effort where everybody's rowing in the same direction, everybody has the same priorities, everybody understands the issue and it is working towards solving it collaboratively. Investments are being made, but they're really insufficient to solve the multitude of supply chain issues. They need to support enablers, like I said, tax incentives, workforce offtake agreements is a big one. We're trying to solve the critical minerals problem. One way to do that and to bring demand back is for the government. We know we're going to need these critical minerals, so buy them as offtake agreements when these companies produce them. That provides them a steady source of demand for at least the first couple of years until they can become cost competitive, get themselves up and running, and bring some of the demand back to be self-sustaining. So that's another way the government can help in that area. Again, using advanced manufacturing techniques is one method we can help to solve some of these issues, and collaborating partners and allies is critical and needs to be part of the overall strategy. So that is all my slides. I know I went through a lot of information very quickly, but I wanted to leave time, so please, happy to entertain any questions.